Hi and welcome back. This will be the last video where we just talk about Go routines, and in the next video we'll finally start writing some code. So the point of this video is to talk more about what's going on in your computer when we create new Go routines and how it handles single and multi-core processors. So this diagram here represents what happens when we spawn multiple Go routines. We have our single core CPU here, or even if you have a multi-core CPU, one core of your CPU then. So the Go scheduler works with this one CPU on our machine, even if we have dual core or a hex core in my case. And we will talk more about CPUs later, but for now, let's better understand what happens with one CPU. So keep in mind that although we are creating more than one Go routine, as like we have 3 here, for an example, only one Go routine is running or executing at a given time. So the job of the Go scheduler is to monitor the Go routines, and when the currently executing Go routine finishes all of its code or reaches a blocking call, the scheduler then gives control to a different available Go routine so that can start executing. So with one CPU, although we have multiple Go routines, only one Go routine is running and no Go routine is running at the same time. Now let's talk about multi-cores. So assuming we have 3 cores right here in our processor, when we have multiple cores, each core can run one single Go routine at a time. So the Go scheduler now assigns each core a Go routine. So we have our 3 Go routines, we have our Go scheduler, and since we're using 3 cores here, the Go scheduler can assign a Go routine to be run on each core. And now that we're using multiple cores, we are truly running multiple lines of code at the same time. And in this last slide here, I want to talk about concurrency and parallelism, because sometimes you might think that they're the same thing when they're actually not the same thing. So concurrency does not equal parallelism. So let's talk about concurrency first. Concurrency is when we can have multiple threads executing code, and if one thread blocks, another one is picked up and worked on. This is what's called concurrent programming, and is the case when we have one core. As in, if something blocks, one of the threads block, we can assign work to a different one. Where in parallelism, it's multiple threads being executed at the exact same time and requires multiple CPUs. This is when you have lines of code running simultaneously at the same time. Like you could have code doing a calculation here for something, and then you have another code over there running at the same time, running some other kind of calculations. So that's parallelism, where code is running at the exact same time. And then in concurrency, it's not code running at the same time, it's just that we're able to assign work to a different thread when one is done or is blocked. And is good examples when we have only one core. So thanks for watching this video. It was quick. It was just a brief, quick discussion on what happens in your computer actually when we spawn multiple Go routines, and if you have a multiple core processor, which most computers do nowadays. And I wanted to quickly discuss that concurrency does not equal parallelism. But finally, in the next video, we will write some code. So thanks for watching, and I'll see you in the next video.